Welcome to Deeksha Online Mathematics. Lecture 5, Quadratic Equations and Binomial Theorem. Let us see what we mean by zero polynomial and identity. Suppose if I take 0, you can write 0 into x power n plus 0 into x power n minus 1 plus so on plus 0. So you can express 0 as a polynomial. You can treat whatever degree you want, you can take it. That's why degree of 0, we say that it is not defined. So suppose if I have 0x square plus 0x plus 0 equal to 0, it is looking like degree 2 here by if you just observe x square term. But you know that it will be satisfied by infinite values of x. So if any equation having more roots than its degree, remember it will be satisfied by infinitely many roots. So such equations are called identity. So main points I will discuss in this chapters. Transformation. Actually you know that alpha, beta, gamma are the roots of some f of x equal to 0. Or you can take alpha, beta are the roots. Alpha, beta, gamma, delta, your wish. Quadratic, cubic, biquadratic, your wish. Suppose if I want equation whose roots are some alpha square, beta square, gamma square. So please remember the quadratic equation which we are asking should be symmetric. The roots, the new roots must be symmetric. Suppose you may ask alpha plus beta, beta plus gamma, gamma plus alpha. So what will be the equation with these two, with these three as the roots? So by using f of x, you can develop the required equations. The procedure is, in the first one, take any one root as x. So alpha will be root x. Take it because alpha is a root of this, no? So f of alpha must be equal to 0. This implies f of root x must be equal to 0. Simplify and eliminate root x. So similarly, suppose if I take alpha plus beta equal to x. So adding gamma on both sides, s1 minus gamma equal to x plus gamma. Or already you have added subtracted this side. So s1 minus gamma equal to x implies gamma equal to s1 minus x. This s1 you can get from the given equation. So gamma will be this s1 minus x, and gamma is a root of f of x. So f of gamma must be equal to 0. So f of s1 minus x equal to 0. If you simplify, you will get the required equation whose roots are this. So anything when the roots, given roots are symmetric, you can use this transformation technique. Common root, same roots. For example, I have ax square plus bx plus c equal to 0, quadratic. Let us take a1, b1, c1. a2x square plus b2x plus c2 equal to 0. Suppose they have a common root. Let that common root is alpha. So a1 alpha square, b1 alpha, like that I can substitute. Then if you treat alpha square and alpha as two variables, you can write cross multiplication procedure b1 c1, a1 b1, b2 c2, a2 b2. So in between these two, alpha square, alpha 1. So you know downward minus upward, downward minus upward, cross multiplication procedure. So alpha square by b1 c2 minus b2 c1, alpha by c1 a2 minus c2 a1 equal to 1 by a1 b2 minus a2 b1. So from this you will get alpha square value, alpha value. So the alpha value, if you square it, you should get alpha square value. That is a condition for common root. And that alpha value which you got here is nothing but the common root. Even from alpha square also you can calculate common root. Suppose if they have same roots, coefficients must be in proportion. Let us see Wavy curve method, which is very, very important. Let us take f of x is equal to x minus alpha 1 whole to the power of k1, x minus alpha 2 whole to the power of k2, so on x minus alpha n whole to the power of kn, where alpha 1 less than alpha 2 so on less than alpha n, k1, k2 so on kn are integers. Now suppose this x takes a real line. I have to see the sign changes of f of x. So this alpha 1, alpha 2, I'll locate alpha n minus 2, alpha n minus 1, alpha n. Those are called critical values. So when you give x, you know that alpha 1 less than alpha 2 so on less than alpha n. So alpha n is the greatest critical value. When x takes more than alpha n, f of x value will be positive. Then at alpha n minus 1, at the critical values, it depends on k1, k2. So if k1 is positive number, at those points it will be 0. If kn, the power kn, k1, k2, anything is negative, it is not defined at that critical value. So according to k1, k2 we will decide. Then from this region to, if you see into this region, means where x takes the values between alpha n minus 1 and alpha n, means greater than alpha n minus 1, less than alpha n. Then the simple logic is, which critical value you are crossing, that factor power you see, if it is, so in this region, if it is kn is even, whatever sign, same sign we will write. If kn is odd, opposite sign you will write. Means suppose if kn is even, what is the sign here? Plus will come. If kn is odd, minus will come. So after deciding that, from here to here we will jump. So which critical value we are crossing? Alpha n minus 1. Its power we will see. If it is even, whatever sign is there, same sign will repeat. If it is odd, whatever sign is there, its opposite sign will come. So this is called Wavy curve method. So location of roots. It is very, very important concept. Everybody know, just a recap. 3 important points you have to take here. The 3 important points are, you know that a quadratic equation will be given. In that some parameter we will keep, some variable. They will say something about the roots. You have to get the conditions. With one example I'll explain. Suppose both roots of f of x are greater than k. So what does it mean? Suppose this is x values, let the roots are beta and alpha, both roots are greater than k, so k will be here. So the first point, so I am telling you 3 points you have to remember. The first point is, when both roots are greater than alpha, there is a chance that alpha and beta can be equal. So the first point we will write on discriminant. So discriminant is greater than or equal to 0. Second point, midpoint of the roots you have to write. So alpha beta, then the midpoint will lie in exactly in between the alpha and beta. According to the diagram, alpha plus beta by 2 is also greater than k. So this is the second point you have to decide. Third point, the value k is outside the roots. You have theorems. I'll teach the theorems also in next discussion. You know that outside the roots, coefficient of x square a and the expression ax square plus bx plus c will have same sign. Means f of k and this a will have same sign. Same sign means their product will be greater than 0. So these are the conditions. So this a is nothing but coefficient of x square. So by using these three conditions, you can solve any problem. Suppose, let us take one more example. If k lies in between the roots, assume k lie in between the roots beta and alpha. So I wrote open interval beta and alpha. K lie in between the roots. So what is the diagram for this? Suppose beta, alpha, k is lying in between the roots. Then what is the condition? First, discriminant. No, you cannot have now equal to 0 because k is in between the roots. So roots cannot be equal. Then second one, midpoint of the roots. So midpoint of the roots, you can't exactly tell with respect to k. So the second discussion won't be there here. Then third discussion, coefficient of x square a and f of k. Because k is in between the roots, coefficient of x square a and the expression at k will have opposite sign. So their product will be negative. So any case, whatever case they give you, please draw the diagram and discuss the three things. What are those three things? Discriminant. Second one is midpoint of the roots. Next, applying the theorem where k is there in between the roots or outside the roots. According to that, you have to decide same sign or opposite sign. Then the theorems. What are the theorems? Now, suppose if delta discriminant of a quadratic equation is less than 0. When it is less than 0, you know that the graph will be upward if a is greater than 0 and it never meets x-axis. So this is a diagram for a greater than 0. So it will be downward if a is less than 0. Now what you can say here, when discriminant is less than 0, for all x belongs to R, ax square plus bx plus c and a will have same sign. Same sign. Observe carefully. When discriminant less than 0, it should not have any root. That's why it should not meet x-axis. But when a is greater than 0, the parabola should be upward. So it is completely above x-axis. Above x-axis means expression value is always positive. So when a is positive, expression value is positive. Similarly, when a is negative, expression value is negative. Now suppose, let us take delta equal to 0. Let us take delta equal to 0. Then you know that it should have a double root. And the double root is minus b by 2a. When a is positive, upward. When a is negative, downward. So the root is, double root is minus b by 2a. Double root is minus b by 2a. So at the root, expression value is 0. Observe, for all other values of x other than the double root, a and expression have same sign. So can I say like this? For all x belongs to r minus b by 2a, ax square plus bx plus c, and a will have same sign. Same sign. Now let us see if delta greater than 0. You know that when delta greater than 0, it should have two real and distinct roots. Let us say beta and alpha. assume beta is less than alpha. Now, when a is greater than 0, it should be upward and should have two roots, means this should be the diagram. So what is the meaning? Observe carefully. When x values are between minus infinity to beta, expression value is positive. From alpha to infinity, expression value is positive. At beta and alpha, it is 0. In between beta and alpha, expression value is negative. See, remember, a is greater than 0. So can I say like this? For all x values outside the roots, expression and a have same sign. In between the roots, opposite sign in this case. Is it valid for next one? When a is less than 0, it should be a downward parabola. Minus infinity, beta, alpha, infinity. So for a less than 0, if you observe carefully, outside the roots, expression is negative. In between the roots, expression is positive. So can I say two bits like this now? When x is in between the roots, beta and alpha, ax square plus bx plus c, and a will have opposite signs. When x is from minus infinity to beta, union alpha to infinity, ax square plus bx plus c, and a will have same sign. So this is next theorem. One more theorem, not sign actually, value. So if a is less than 0, it will be a downward parabola, no? So for all x belongs to R, it will have a maximum value at minus b by 2a, and the value is 4ac minus b square by 4a, vertex of the parabola. If a is greater than 0, it will be a downward parabola. So same minus b by 2a, comma 4ac minus b square by 4a is a vertex. Means at x equal to minus b by 2a, the quadratic expression for all x belongs to R will have a minimum value 4ac minus b square by 4a. Multiple roots. See, as you know, in quadratic equation, if discriminant delta equal to 0, then it should have double root. So multiple means for higher degrees. Suppose if you have f of x equal to 0, nth degree equation, let us say nth degree equation, let alpha is a multiple root of multiplicity some m, let us say. So what do you mean by that? That f of x should have x minus alpha m times into some more polynomial you should have. Then please remember that suppose if I do f dash x minus alpha whole power m into g dash x plus g of x into m into x minus alpha whole to the power of m minus 1. So I can write x minus alpha whole power m minus 1 into common, if I take some h of x, I can show. And please remember here f of x should be equivalent to x minus alpha whole power m into g of x, where g of alpha should not be 0. Then only alpha will be a multiple root of multiplicity m. So here h of alpha won't be 0. So what you proved? Alpha is a multiple root of order. You can say multiplicity or order, anything. Multiple root of order m minus 1 for derivative. So please remember, whenever you have equation, suppose you have a 10th degree equation, for that equation 2 is a multiple root of order 5. Then for its derivative equation will be a 9th degree equation, the same root 2 will be the multiple root of order 4. So this is very, very important point. Next, Decarte's rule of sign changes. Suppose f of x as sign changes some k1. Assume this is nth degree. And f of minus x sign changes are some k2. So maximum number of positive roots will be k1. So number of sign changes in f of x, this k1 will give you maximum number of positive roots. Positive roots. Maximum number of negative roots will be k2. So in f of minus x, how many sign changes are there? So many maximum number of negative roots will be there. Then if you add, it will be maximum number of real roots will be k1 plus k2. Then minimum number of imaginary roots will be n minus of k1 plus k2. So this is Descartes' rule of sign changes. So while solving higher degrees nature of roots, we will use this concept. So transformation of the equation for requirement. So what are the requirements? Suppose I'll take one example. Ax power n plus bx power n minus 1 plus so on. Okay, I'll take a0, a1, so on, an. So a0 x power n plus a1 x power n minus 1 plus so on, an equal to 0. So assume that this is f of x. You know by Taylor series f of x plus h. So f of x plus h will be, what is f of x plus h will be? F of h plus f dash h by 1 factorial into x plus f double dash h by 2 factorial into x square plus so on, f nth derivative at h by n factorial into x power n. So this is Taylor series. Now you know that this f of x plus, when f of x is there with nth degree, it will have n roots. If I calculate f of x plus h equal to 0, it will be a new equation, transformed equation, where roots will be decreased by h, because plus h, no? So roots will be decreased by h. Now that is a transformed equation, assume. In the transformed equation, suppose I don't want required term. Means suppose, for example, I don't want second term. What do you mean by I don't want second term? Second term means actually this is written in reverse order. Constant x coefficient x square means I don't, in the transformed equation, I don't want second term. I don't want second term. So second term I don't want means I don't want x power n minus 1 term. So what I should do? What will be the coefficient of x power n minus 1 in f of x plus h? It will be the n minus 1th derivative. N minus 1th derivative should be equated to 0. Now you observe carefully, what is the n minus 1th derivative of f of x? N minus 1th derivative. I think x power n minus 1th derivative. For example, you see x power 5, first derivative 5x power 4. Second derivative 5 into 4 into x cube. Like that, fifth derivative will be 5 factorial. Before derivative, fourth derivative will be 5 into 4 into 3 into 2 into x you will have. So can I say the only difference is 1. So can I tell that the n minus 1th derivative of a0 x power n will be a0 into n factorial into x, but I want at h, no? So I am substituting at h. So that is what? N minus 1 the derivative of x power n at h. Then next term a1 x power n minus 1 the derivative will be n minus 1 factorial, and later all terms will have x powers lesser than n minus 1 powers of x will be. So all derivatives will become 0. So this will be the n minus 1 the derivative of f of x at x equal to h. So this should be 0. So if I make this 0, what will happen? in the transformed equation, second term won't be there. Second term meaning is x power n minus 1 term won't be there. Then what is the h value? H value is minus a1 by n a naught. So can I say this is nothing but minus a1 by a naught is nothing but s1 by n. Can I call this as, in statistical language, average of roots? So please observe, if I choose h as average of roots, in the transformed equation, you don't find second term. Actually, this concept is developed for solving cubic equations. Suppose ax cube plus bx square plus cx plus d equal to 0. This is a full-fledged form of cubic equation. Suppose if I transform this cubic equation to remove the second term, means this term will be removed in the transformed equation. Then only cubic term, x term, constant will be there. Then you have to transform the roots. By using this transformation h equal to s1 by n, you have to calculate f of x plus h. That equation is called Cardan's equation. So there is a procedure given by Cardan how to solve cubic equation in which x square term is not there. So after getting that roots, you have to backshift, because that is a transformed equation where roots will be lesser than by h. Then again, if you add h, you will get the required roots. Okay, that Cardan's, all those things are not there, but this elimination is very, very important concept. Okay, other type of conversions are also there. I took one example in the problems. You can see that problem while watching the problems video. Then reciprocal equations. So what do you mean by reciprocal equation? A reciprocal equation is, if alpha is a root for the given equation, 1 by alpha is also a root. If alpha is a root, then 1 by alpha will be a root. Then can I say that for given f of x should be equivalent to f of 1 by x also? Then from that, what you will get? There are two possibilities you will get. A I equal to plus or minus a n minus I you will get. A I equal to plus or minus a n minus I. Means you take f of x as some a naught x power n plus a1 x power n minus 1 plus so on a n. F of 1 by x you calculate. Those two should be same. So coefficients, if you compare, you will get ai equal to plus or minus a n minus I. Means first coefficient, last coefficient, second coefficient, last but coefficient, they will be equal, or their sum, corresponding sums will be 0. There will be two possibilities for reciprocal equations. Suppose if ai equal to, if you have plus sign, that is called reciprocal equation of type 1. And if you have minus, it is called type 2 reciprocal equations. Remember, so that meaning is type 1, for type 1 a naught equal to an, a1 equal to an minus 1, like that. For type 2 a1 equal to minus an, a2 equal to minus an minus 1, like that. That is for type 2. Now let us see some examples. Now suppose the reciprocal equation even degree type 1 I want. So let us do with some example. So even degree, let us take fourth degree, some 2x power 4 even degree. So it is type 1, no? So it should end with 2. Then what is the next term? X cube term. X cube term, suppose let us say some 3x cube. So can I say it should be some 3x? Then next term will be some 4x square. I think from that side also same position. That's why it should be equal, no? So minus 4 from this side, minus 4 from that side, that coefficient should be equal to 0. So this is even degree type 1. This is called reciprocal equation of even degree type 1. So how to solve this? The procedure to solve even degree type 1 is divide with the middle term. Term means not with 4, only with x square. Here x square. So really speaking, What is the degree? With half of the degree term you have to divide. Means you have to divide with x square. So what will happen? 2 times x square here. Here the last term, first term, last term if you combine. So 3 times x plus 1 by x minus 4 you will get. So if you divide with x square, so it's actually x power n by 2 where n is the given degree because it is even. Now we will assume here, let x plus 1 by x equal to some y. Then it is given as 2y square plus 3y minus 4. Quadratic, you will solve for y. Those y values you will again take in this substitution. Then you will get quadratic in x for 2 values of y. So x will have 4 values. So this is a way how even degree type 1 you will solve. Next, odd degree type 1. Carefully see odd degree. So let us take x power 5. So type 1, no? That's why it should be plus 1 only, because type 1 it is. Then suppose minus 4x power 4, then it should be minus 4x, because it is type 1. Odd degree type 1. Next, if I write 2x cube, from that side how much you should have? Plus 2x square you should have. So is it correct or not? It is odd degree, yes. Type 1 means first quotient, last quotient equal, second last but one, third from last, third one. So it is type 1 and odd degree. Anything you are observing, that is very, very important. Substitute 1. Is 1 satisfying this equation? No. Minus 1 will satisfy. 100% it will satisfy. Why? Because it is odd degree, no? So if I substitute minus 1 power odd will be minus 1, but the type 1, no, the last plus 1 will get cancelled. Like that, here it is even power, here odd power, here odd power, even power. So if you substitute x equal to minus 1, it will satisfy. Please remember, for any odd degree type 1, it is a trivial, means compulsory root. X equal to minus 1 is a compulsory root. Now let us do synthetic division. 1 minus 4, 2, 2 minus 4, 1. Now with x equal to minus 1, if I do synthetic, minus 1, minus 5, 5, 7, 7 into minus 1, minus 7, 5, minus 1, x equal to minus 1. Okay, correct. 1. So minus 1 into 1, minus 1, minus 5, 5, 7. So minus 7 plus 2 is minus 5. Minus 5 into minus 1, 5. 5 minus 4 is 1. 1 into minus 1, minus 1. So it will be 0. Yes, minus 1 is a root. That's why you got like this. So it's a fifth degree, no? I did synthetic division with x plus 1. Its meaning is, so leftover will be x power 4, fourth degree, minus 5x cube plus 7x square minus 5x plus 1 equal to 0. Did you observe anything? So for odd degree type 1, minus 1 is a compulsory root. So if I divide with minus 1, I will be left over with a fourth degree equation. But if I observe carefully, it is even degree type 1. How to solve even degree type 1? I have a procedure. You have to divide with the x power degree by 2 and combine them, and you will take x plus 1 by x equal to y, and you will solve that equation. So please remember, odd degree type 1, minus 1 is a root. If you do synthetic division, it will take the form, means remaining equation will be even degree type 1, which we can solve. Okay, now let us discuss odd degree type 2 now. It is type 2. So let us start x power 5, some minus 1. So plus 2x power 4, then you should have minus 2x plus 3x cube. Then from that side you should have minus 3x square. So everything is perfectly settled. So it is odd degree type 2. Now observe carefully. If I substitute minus 1 now, I think it won't be a root, because first term is odd and last term is its opposite sign. Coefficient is opposite coefficient. That's why I think if you substitute x equal to 1, now it's a trivial root. X equal to 1, it will be a trivial root. So let us take the coefficients 1, 2, 3, -3, -2, -1. Synthetic division with 1. 1, 1's a 1, 2 plus 1, 3, 3, 3 plus 3, 6, 6 1's a 6, 6 minus 3, 3, 3 1's a 3, 3 minus 2, 1, 1 into 1, 1, it will be 0, the last remainder it is. Now it's fifth degree, no? X minus 1 you are dividing. So you will be left over with x power 4. This is the quotient, x power 4 plus 3x cube plus 6x square plus 3x plus 1. Again, anything you observe? It's type 1 even degree, which you know the procedure to solve. Divide by x square and solve it. So please remember, if it is odd degree type 2 also, x equal to 1 is the compulsory root. And if you do synthetic division with x equal to 1, you will be left over with a type 1 even degree which you can solve. Then even degree type 2. So let us see type 2. So let us take x power 6. I'm taking x power 6. So minus 1 plus 2x power 5. Then I should have minus 2x plus 3x power 4. Then I should have minus 3x square. Then what I should have in middle? Suppose if I write here some 5x cube, from back side I should have minus 5x cube because it is type 2. So x cube term should not be there. So only this is the equation, x power 6 plus 2x power 5 plus 3x power 4 minus 3x square minus 2x minus 1. So that middle term should not be there because the middle position is from first and from last same position you have. But according to type 2, it should have coefficient from this side and from that side, the sum must be 0. So additive inverse to each other. So 0 should be the coefficient of that term. So the term won't be there. Now please observe carefully. So our equation is x power 6 plus 2x power 5 plus 3x power 4 minus 3x square minus 2x minus 1 equal to 0. So if you observe carefully, x equal to both plus 1 minus 1 will satisfy this equation. Now compulsory solutions are 2. What will happen if we do synthetic division with this x square minus 1? So what is the quadratic with x plus 1 and x minus 1? X square minus 1. If you do the synthetic division, so 1, 2, 3, 0, minus 3, minus 2, minus 1. You know with sum and minus product. So what is the sum? 0. Product is minus 1. Minus product is 1. So you will do synthetic division. So you will write 1. 1 into 0. 0. Nothing is there. 2. 2 into 0. 0. 1 into 1. 1. Here 4. 4 into 0. 0. 2 into 1. 2. You will get 2. 2 into 0. 0. 4 into 1. 4. 4 minus 3, 1. 1 into 0, 0. 2 into 1, 2. You will get 0 here. And please remember, this is not the quotient part. It is a remainder part, because when you are dividing with quadratic, remainder must be ax plus b model. Last two numbers will go into remainder part, ax plus b. So this is cross here. Means 0 cannot be used for. Then the previous one, 1 into 1, it will be again 0. So you got remainder as 0x plus 0, which is 0. So observe this leftover part. It is x power 6 dividing with a quadratic. So you should be left over with x power 4 plus 2x cube plus 4x square plus 2x plus 1 equal to 0. Again it is even degree type 1, which we can solve. So these are the 4 types of reciprocal equation, and those are the procedure how to solve them. Then let us come to binomial theorem and multinomial theorem. So you know, very familiar with binomial and multinomial. So binomial theorem, you will take only two terms, x plus y whole power n, which is summation of NCR x power n minus r y power r equal to 0 to n. And this term, you know, general term we call. Lot of problems, middle term, required terms, required coefficients, everything you can use general term. Then multinomial theorem means, suppose you have x1 plus x2 plus so on xm whole power n is, it will contain the terms of the style x1 power q1, x2 power q2, so on xm power qm. So it will have a coefficient of n factorial by q1 factorial, q2 factorial, so on qm factorial, summation of all such terms. So how many such terms? There is a equation q1 plus q2 plus q3 plus so on q3 plus so on plus qm must be equal to n. So how many roots are there for this equation? So many terms will be there in this sigma. This is called multinomial theorem. And what is NGT, NGC, NGBC? See, NGBC is nothing but, no need of n here, greatest binomial coefficient. So you know that if n is a given power, NC naught, that is C naught, C1, so on, Cn are the binomial coefficients. In this, if n is even, NC n by 2 is the greatest binomial coefficient. If n is odd, NC n minus 1 by 2 and NC n plus 1 by 2 will be equal, and they are the greatest binomial coefficients. Then what is this NGT and NGC? You know, this we will develop for 1 plus x whole to the power of n. So any other question we will convert into this model to calculate NGT and NGBC. So to get NGT, they will give some x value. By n value and x value, you will calculate n plus 1 into mod x by mod x plus 1. This will have two chances. One, you can get some p which is integer, some p plus f, where p is integer, f is fraction. So in this case, tp and tp plus 1 will be equal, and those two will be NGTs. In this case, tp plus 1 will be NGT. So please remember that formula, n plus 1 to mod x by mod x plus 1. Now, if you are given some a plus bx whole power n, so you will take a power n common, 1 plus bx by a whole power n. Then b by a also will enter into the coefficient NGC, it is numerically greatest coefficient. Then what you will do? In this, you will calculate NGT only, but for the value of x equal to 1 you will calculate, because if you put x equal to 1, the NGT will become NGC, that's all. So NGT will become NGC. Please remember this concept, very important concept. Then reduction and reverse of reduction. So instead of reduction, you can use differentiation. Reverse of reduction, you can use integration. Both procedures are important. Learn both. Differentiation, integration you learn. Reduction, reverse of reduction also you learn. So what is the meaning? You know, there are some properties regarding binomial coefficients. That is C0 plus C1 plus so on Cn equal to 2 power n. Now, suppose if I ask you, what is sigma r into Cr when r equal to 0 to n? So what is the meaning? 0 into C0 plus 1 into C1 plus so on plus n into Cn. What is its value? You can use differentiation to solve this. But what I want to do, sigma r equal to 0 to n, r into Cr I can write NCr, which I can write n by r into n minus 1 c r minus 1. R gets cancelled. So this is called reduction. NCr is reduced to n by r into n minus 1 c r minus 1. So that r gets cancelled. This n is independent of sigma. You can take it outside, n into. Then from r equal to 0 to n, if you expand this, it will be n minus 1 c0, n minus 1 c1, which is 2 power n minus 1. Now exactly reverse. Suppose if I ask you, what is Cr by r plus 1 when r equal to 0 to n? This model you can solve using integration. Now, how to use reduction? Reverse of reduction. So Cr I want to develop from n plus 1 c r plus 1. So what is n plus 1 c r plus 1? Can I write n plus 1 by r plus 1 into n cr? Now that I want to use here. So 1 by r plus 1 into r plus 1 by n plus 1 into n plus 1 c r plus 1. That is called reverse of reduction. So r plus 1 gets cancelled. So I can write 1 by n plus 1 outside. Then if you put r equal to 0, it will be n plus 1 c1, n plus 1 c2, it is starting. So it is 2 power n plus 1, but n plus 1 c naught is missing, so minus 1. So this is reduction and reverse of reduction. Using this, you can find sigma r square into cr, r cube into cr. What I should do? R square, if you have that r square, you have to write r into r minus 1 plus r. Separate it and do the reduction. Sum of coefficients. See, suppose you have any binomial or multinomial f of x, a naught plus a1x plus a2x square plus so on an x power n. See, if you do f of 1, you will get sum of all coefficients. If you get f of 1 and f of minus 1 by 2. See, there is no need to by heart this as formulas. Just I am telling that take that expansion as some polynomial and try to use f of 1, f of minus 1, f of I, f of omegas. According to given question, you have to use all these things. Sometimes there may be a necessity to use complex numbers. That is De Moivre's theorem and binomial theorem combinations also useful. So f of I, f of omega. So if what happens according to the combinations of the questions, suppose a person is asking what is a0 plus a3 plus a6 plus so on in this expansion. So a0 plus a3 plus a6. So if I use omega, omega power 0, omega power 3, omega power 6, all are ones. So like that you should get idea. So suppose f of I, what will happen if I use f of I, a0 minus a2 plus a4, like that I will get. So according to the given question, you have to use sum of the coefficients. So what will happen if f of 1 minus f of minus 1 by 2? So you will get sum of odd suffixes. F of 1 plus f of minus 1 by 2. You will get sum of even suffixes. So this is in general. These things we can apply for binomial expansions also. Suppose if 1 plus x whole to the power of n. So what you will have? c0 plus c1x plus c2x square plus so on cnx power n. Suppose if I substitute x equal to I. So right side you will have c0 minus c2 plus c4 so on plus I into c1 minus c3 plus c5 so on. So it will be 1 plus I whole to the power of n. So this 1 plus I whole to the power of n also, by using De Moivre's theorem, you can expand in the form of a plus ib. That is root 2 cis pi by 4 whole to the power of n, which is nothing but root 2 whole power n cis n pi by 4, which is cos n pi by 4 plus I sin n pi by 4. So if you compare real part with real part, imaginary part with imaginary part, you can calculate the required quotient. So in binomial theorem, always if you observe question carefully, question will tell you what to do. So what expansions you have to take, what expansions you have to equate, which coefficient you have to equate. So everything question will tell you. So observe the question carefully and solve. Then summations. So what do you mean by summations? Suppose sigma I equal to 0 to n, sigma j equal to 0 to n, ai, aj. In this case, we call INJR independent. Remember, INJR independent. So in this expansion, we will take all I less than j terms, I equal to j terms, I greater than j terms. So all terms we will take. So INJR independent when I said. So this ai I can shift, means I can simplify this. I equal to 0 to n ai into sigma j equal to 0 to n aj. So I can tell that this is nothing but ai whole square, because only variable is changing, or your wish you can say j equal to 0 to n aj whole square also. Why? Because it is only variable change. I said INJR independent. Then it will be simply, you can separate the sigmas. Let us apply the binomial. Now this is nothing but what? I and j are independent, no? Sigma I equal to 0 to n ci whole square, because the other one is also same. So it is nothing but what? 2 power n whole square, which is 2 power 2n. So let us see this as an example, or how to expand this. I said it is what? Independent. So can I write like this? Sigma I equal to 0 to n, sigma j equal to 0 to n, I into ci into cj plus sigma sigma. So I'm not writing I equal to 0, that please think that it is there, j into ci cj. Now I told you, whenever you have this type of sigma structures, please remember that they are I and j are independent. So I can move, means I equal to 0 to n ICI into 1 into sigma j equal to 0 to n cj. Similarly, sigma I equals to 0 to n ci into sigma j equal to 0 to n j into cj. So what you will get? I into ci. Do you remember what is I into ci? Is it n into 2 power n minus 1 into what is j equal to 0 to n cj? 2 power n plus I equal 0 to n ci will be what? 2 power n into n into 2 power n minus 1. Like that you will simplify. Please remember, whenever you have this type of sigma structures, I and j are independent, you can move like that. Then whenever you see this type of structures, remember I and j are dependent. I and j are dependent. So in this, one should understand, when I is less than j, that sum is equal to the sum when I greater than j. So in this expansion, in this type of styles, whenever I is less than j, whatever sum you will get, I greater than j also same sum you will get. Then how to evaluate this? It's very simple. So the previous one, when they are independent, that is I equal to 0 to n, j equal to 0 to n, which I told sigma I equal 0 to n a whole square you can write, no? So by using that property, so in this expansion, what are there? 0 less than or equal to I less than j less than n double sigma ai aj plus double sigma I equal to j ai aj plus double sigma 0 less than or equal to j less than I less than equal to n ai aj. I told this and this will be equal when I and j are dependent. So I can say this is how much? I equal to j ai aj means what? I equal to j ai aj. That is ai like that, ai square like that. Now our requirement is this. So can I say our requirement is equal to the summation when I equal to 0, that is independent to n, j equal to 0 to n ai aj minus the sum when I equal to j ai aj divided by 2. This will give you the required sum when I and j are dependent. Now suppose if I want to calculate this one, means same thing I want to apply for binomial. So what should be this equal to? Because this says that I and j are dependent. So I equal to 0 to n, j equal to 0 to n, ci cj. This is a whole sum minus, from this what I am doing, double sigma ci cj, that is I equal to j whole by 2. This will give you the required sum. This is nothing but what? 2 power 2n minus what about this? I equal to j ci cj means c0 square plus c1 square plus so on. I think you know that is 2n cn by 2. So this is the value of this double sigma. So please remember these two structures, when I and j are independent, when I and j are dependent. Observing this, you can solve the problem. Then binomial theorem for any rational index. You know that binomial theorem for any rational index 1 plus x whole power n is 1 plus nx plus n minus 1 n into n minus 1 by 2 factorial into x square plus so on to infinity. So if n is finite, x can be any complex. If n is finite, x can be any complex number and the expansion will be finite. But if n is negative, then x should be between -1 and 1 and the expansion becomes valid infinite expansion because we are taking x as -1 to 1. So please learn this formula 1 plus x whole power n minus n. I am writing very strictly x positive and n is also natural number or okay, whole number waste 0 if you take, it's waste of discussion. So n is a natural number, means this minus sign if I see, that is a negative power because I kept condition n is a natural number and I took x is positive. That's why I am discussing both plus and minus. So x is positive I am discussing. So what is the formula for this? It will have a infinite expansion and x will have a condition. It will be between -1 and 1. So what is 1 plus x whole to the power of minus n? So please remember, whenever you have like this, you start with n minus 1 c naught, and when you have plus inside and power is opposite sign, power is minus, inside x coefficient is positive. So if you have like that, alternate plus minus you have to take. So minus nc1, start with n minus 1 c naught, alternate plus minus, increase both ncr structure, increase n and r both, nc1 into x, alternate plus n plus 1 c2 x square minus n plus 2 c3 x cube, so on. So n minus 1 c naught, nc1, n plus 1 c2. So if you observe carefully, x power r, c r suffix will be r, but here n plus r minus 1 will get, minus 1 whole power r will be there. So when it is like this, when you have 1 minus x whole power minus n, so when you have minus here, all will become plus. So n minus 1 c naught plus nc1x plus n plus 1 c2 x square plus so on. These are the formulas. Then if the power is fraction, so there are 4 possible formulas here. 1 plus x whole to the power of p by q. Formula will be 1 plus p into x by q plus p into p minus q by 2 factorial into x by q whole square plus p into p minus q into p minus 2q by 3 factorial into x by q whole cube plus so on. Then 1 minus x whole to the power of p by q will be 1 plus it will be 1 minus p into x by q plus p into p minus q by 2 factorial x by q whole square minus 1. Observe carefully what is happening. When here plus power is also plus, you have all plus. Here minus power is plus, you have alternate plus minus. And if you observe carefully, suppose if I write 1 plus x whole power minus p by q. Now fraction is a negative fraction. Then here plus is there, power is minus. So you should get alternate plus minus. But the difference, please observe, the difference is this. Are you observing? It is 1 plus p into x by q, p into p minus q by 2 factorial. How the terms are? That the terms are the product in which they are in AP. P minus q, p minus 2q, like that, p minus 2q, like that. So here p plus q, like that, means increasing AP. The decreasing AP is here increasing AP. Whenever you have power positive fraction, it will be decreasing AP. When the power is negative fraction, it will be increasing AP. Now you tell me what will be 1 minus x whole to the power of minus p by q. When both are of same sign, minus minus, x coefficient is minus, fraction is also negative. all plus you will get. So 1 plus p into x by q plus, since the power is negative, increasing AP you should have, p into p plus q by 2 factorial x by q whole square plus so on. Again I am telling here very clearly, I am taking x positive, p q are also positive and q not equal to 1. p q are positive and they are not equal, q is not equal to 1. Means purely a fraction with plus or minus have to keep. So inside PQ, when P is positive, PQ is negative, those discussions I don't want to do. Okay, thank you. Let us discuss some problems.